Hello everyone, how are you doing? I'm gonna do some examples regarding improper integrals, but I'm gonna do some easy one first, and it's not really the easy one, but it's very important in the future when we talk about sequences and series. And those are when something, the upper bound is increases to infinity and the bottom is 1. And those are is going to become a reciprocal function such as 1 over x dx. Therefore, this is one of those improper integrals because the upper bound is not a finite quantity, and since it's not a finite quantity, I have to find out the value of indefinite integral. In order to really see it, first you have to go ahead and picture the graph and see the area under the curve. 1 over x when x is 0 is undefined, and when x is infinity is 0. At least my graph on the positive side is this. And I'm going to start from 1 and it's going to go to infinity. And remember, this goes forever and ever and ever and ever and ever and ever. And the graph tilted toward the x-axis. That's the reason they call the x a horizontal asymptote. And I want to know really what is that area under that curve is. Is it a converges to a finite number or really gets so huge is a big piece of property and I don't know what is the square units is. Therefore, I don't know how to solve the improper, but I got to change it to a proper one. I'm going to call it A, 1 through A. And remember, that A is a number that approaches toward the positive infinity. Therefore, I got to take the limit and allow A approaches plus infinity. All you got to do, call this one a proper definite integral, solve that. Whatever the area of under the curve is going to be in terms of A, then take the limit. Okay, what function is derivative is 1 over x? It's a natural log of x from 1 to A. And that becomes natural log of A minus natural log of 1. Natural log of 1, 0. The area under the curve is natural log of A. If A is 2, the area under the curve is natural log of 2. If it's 3, natural log of 3. 10, natural log of 10. 100, natural log of 100. But what is the area as A approaches infinity of natural log of A? My A goes to infinity. Therefore, remember, this is nothing except y equal to natural log of x. And when you graph natural log of x, which is a reciprocal, which is the inverse of exponential function, as you go from 1, that area get larger and larger and larger, and it doesn't have any convergence. Therefore, it goes forever. Therefore, what is natural log of infinity? Means at infinity, if the x is infinity, what is that one? Is infinity. Therefore, you know this one is going to say diverges. But remember what that power was. That power was 1. And remember, I could not use the power rules because if I apply the power rules, when I add 1 to it, therefore the bottom becomes 0. Therefore, every time the power is -1, you cannot apply the power rules because denominator becomes 0 and the answer would become a natural log. I'm going to do one with the power less than 1, which is not a natural log. Okay, 1 through A, 1 over x to the power of 1/2 dx. And I'm going to take the limit as A approaches infinity. Remember, that's 1 through infinity, same thing, but I'm going to make the power less than 1. This one I have to say x to the power of -1/2 dx, but in here I can apply the power rules. What is the integral of, what is the antiderivative of that one? X to the power of -1/2 plus 1, which is 1/2, divided by 1/2, which is the same as multiplied by 2. Therefore, the answer to this one is 2x to the power of 1/2, and you take the limit, and you're going to evaluate it from 1 through a, and you take the limit as a goes to infinity. Well, is the limit a goes to infinity? I'm not worried about that right now. And it becomes 2 square root of a minus 2 square root of 1. I know 2 square root of 1 is 2. But what is a square root of a large number? It is a large number. Therefore, when I take the limit and a become infinity, you're going to have a huge number minus a 2, and that become huge. Therefore, this also diverge. Remember, when the power become less than 1 is a natural log. And the natural log, when you go to infinity, the area get larger and larger and larger. When the power is less than 1, it go to the top, you add 1 to it, the power become positive. You no longer you have to bring it down. If you bring it down, there would be a different story, because when you divide 1 over infinity, it becomes 0. Let me take another power and say, no, this time I'm going to make x to the power of not negative 1/2. I'm sorry, 1/2. I can put 1/3. It give me the same thing. To the power of 0 is 1. I'm going to put a negative 1. 1 to infinity. This one I have to write the limit as a approaches infinity and make it a definite integral. But what happens when the power it become negative 1? You bring it upstairs. And the integral of x squared over 2 from 1 to a, and that become a squared over 2 minus a 1/2. But if I take the limit of a squared over a 2 minus a 1/2, a goes to infinity, the limit of a constant is a constant. But what is infinity a square? Infinity over 2 is huge. Therefore, this also diverges. Therefore, you see when the power is 1 or less than 1, especially when it gets to from, for example, 0 to 1, like 1/3, 1/4, 1/2. No matter if it's 1/2, you bring it upstairs, become negative 1/2. But when I add 1 to it, it become positive. It no longer go down. Even if it's 1/4, then when you take the 1/4 upstairs, become negative 1/4. And when I add 1 to it, it doesn't come down. And then because it doesn't come down, when you replace infinity with it, it diverges. Then from today, you have to know, if I put 1 over x to the power of p, dx, p, I'm going to tell you what it is, from 1 to infinity. If p is less than or equal to 1, you better know this is going to diverge. Because you solve for 1, you solve for 1/2, you solve for 1/4, power of 0 means 1, integral of 1 is x, and when x go to infinity is infinity, and I did it for negative 1, when negative 1 come upstairs, become plus 1, and it become x, and it become x squared over 2. Therefore, from today, you have to know, if you go from 1 to infinity, a 1 over x to the power of p, and that p is less than or equal to 1, that improper integral diverges. Means area under the curve, it gets larger and larger and larger. Let's test to the right of one. Okay, when it go from 1 to infinity, but I'm going to put to the right of 1, I'm going to pick 2. It doesn't matter. You can put 3/2 2. The beauty about it is, if it's more than 1, in order to integrate it, you have to move it upstairs. The power become negative. And when you try to find the integral, when you add 1 to that one, because it's already, this number is more than 1 and is negative, the answer is going to become a negative number. And it had to go back down the stairs. Therefore, for that one, I'm going to use 2, not 3/2. And I'm going to write the limit as a approaches infinity of integral of x to the power of -2 dx from 1 through a. Remember, when I add 1 to this one, it become a negative. And it had to go down the stairs. Therefore, when I put x minus 2 plus a 1, do you remember in this one, when it was less than 1, when you move it upstairs, then you add another 1, it stay positive, you don't have to move it down the stairs. But in here, you have to divide it by -1, that become -1, and that become -1, it become down the stairs. When it come to down the stairs, it become -1 over a minus -1 over 1. And when you take the limit as a approaches infinity, what is 1 over infinity? 1 over a huge number, that number approaches 0. Therefore, in here you have 0 plus 1. And what is 0 plus 1 mean? That area under the curve converges. Somebody said, okay, why don't you do 3 dx? Well, in order to change it to the proper one, first you have to make this one a, b, c, whatever you want to call it, and make sure a is approaching infinity. But in order to integrate it, you have to use power rules. You cannot use chain rules, or you don't want to do trig substitution. That's easy because the base is a naked x. You just move the x to the top, dx, and you integrate it. But what is the integral of that one? You add 1. But when you add 1, because that number is already bigger than 1 and is negative, it will stay negative. And when it stays negative, you have no choice to bring it down. Then when you put infinity right here, it makes it a 0. That's why it converges. And this is the same as -1 over 2x squared. Right now, I'm going to do that. -1 over 2x squared from 1 through a, it becomes -1 over 2a squared minus -1 over 2 times 1 squared. What is negative times negative? Positive. That's a plus half. But the other one is -1 over 2a squared. But right now you have to take the limit as a approaches infinity. Then if this one approaches infinity, 1 over a huge number approaches 0. Therefore, this approaches 0. Approaches 0. Means 0.00001 or something. Plus 1/2. Then you better say this approaches 1/2. But I don't know if it approaches 1/2 or it approaches 0.1111 or 0.499 or 0.44999, but it's in the neighborhood of these, and they call this one converges. Then from today you have to know, if you have an improper integral from 1 to only from 1 to infinity, because this one you cannot put 0 here. And somebody said, why don't you put 1/2? It doesn't matter if you put 1/2. Still your answer is going to be the same, but I don't want to go in here and plug in 1/2 for my a when I integrate it like here. I don't want to plug in here with 1/2. 1 over 1/2 became a 2. It still is going to converge. Therefore, I'm going to start with a number of easy 1 and go to infinity with the power of p dx. From today, you have to know, if the p is less than or equal to 1, it's going to diverge. You got to know that. The area under the curve get larger. And if p is greater than 1, remember, equal is tied to a divergence. But if p is greater than 1, it converges. Like this become 1.5, 1.5, 1.6, 2, 3. Because when you move it upstairs, like 1.5, when you move it upstairs, it becomes -1.5. But when I add 1 to it to integrate it, it will stay negative and it must come down the stairs. And then when it comes down the stairs, when you replace infinity for it, 1 over infinity make it a 0. Therefore, from today you have to know this is called P series. What is the P series? What they call it a P? Because they chose the power P of dx from 1 to infinity. You cannot put 0 because 0 is not part of the domain, but you can put 1/3, 1/2, but it doesn't matter. I'm looking for convergence or divergence. You want to say converges. I don't care if it converges to 3 or 5 or 100. All I need is a word of convergence or diverges. Therefore, if P is less than or equal to 1, remember 1 is your border. All these numbers make it diverge. But if not one, all these numbers become converges. Therefore, P greater than 1, converge, P less than or equal to 1 is diverges. Why diverges? Because when this number become a number less than 1, like 1/2, if you want to integrate it, you have to move it upstairs. And because that number, that become a negative 1/2, because that number is less than the one you're trying to add, it stay positive and you don't have to move it downstairs. Therefore, when you put infinity to some power, that become diverges. But in here, your x is greater than 1. When you bring it upstairs, when you add 1 to it, that's stay negative. This stayed positive because that number was less than a 1 all the time. And this stayed negative. But because it's a negative, you have to bring it down the stairs. And then when you replace infinity for it, it becomes 0. Therefore, you got to know the P series. The convergence is P greater than 1. The divergence is P less than or equal to 1. That's very important for the sequences and series, and we call it the P series. Like somebody said, give me the answer, please. What is 1 over x plus 5 dx from 1 to infinity? Converges or diverges? I'm going to say, sir, when you go to infinity, what is, like, give me an example. What is a million plus a 5? Somebody has $1 million, I give him $5. Really, that $5 I gave them is very minimal. Therefore, that constant, who cares about that constant? This one is still diverges. If I put 1 over x squared plus 3x plus 7 dx from 1 to infinity, remember, when this go to infinity, let's put a million for x. Million squared is a huge number, but 3 times a million is only 3 million. Who cares about this? You have to look at the leading variable, and if the power of a leading variable is greater than 1, you're going to say this one is going to converge. And if the leading variable, the power is 1 or less than 1, you're going to say diverges. That's an example of improper fraction. I'm going to make this video short. I'm going to give you some more example in the next video. Thank you.